field of astrophysics and all other related domains, and will be start talking about the most sustainable and the most known theory that interprets and explains the origin of the creation, the beginning of the creation, which is the Big Bang. So this theory is supported scientifically with some proofs and evidence, and keeps being confirmed by new research, especially in the field of technology and the way we are developing telescopes so we can just be able to examine more galaxies, and even the far distant galaxies, and also with the discovery of the new waves and microwaves. So the first finding about the Big Bang was in the Bell Labs in New Jersey by two notable researchers who had examined the cosmic background radiation. So this cosmic background radiation, from the length, the shortness of the length of the wave, they had presumed that this was supposed to be leftover radiation from the Big Bang, from the earliest time. And so those waves are to believe that they were the first that were produced after the expansion of the universe. Now, to explain what is a Big Bang, most of the people think that it is a big explosion. However, the theory does not stipulate that. It just talks about one singularity that has high density and high energy, infinitely high density and infinitely high energy, and it start expanding. So the space start expanding. Now, what is the shape of the universe? To discuss that matter, there are many theories about that and many ideas, but there is no certainties and no proofs about the final shape of the universe. Now, those radiation, the lifetime of those radiation go back to around 13.7 billions of years. This is how they had determined the age of universe, or the universe started from ago. So now the finding also about the universe is cooling off. Not only is expanding, it's not only expanding, but also is cooling off. So if they had measured for now the temperature of the universe, the general temperature, it's about 2.7 Kelvin, which is around minus 270 degrees Celsius. And now with some techniques that they had using the redshift, which is an increase in wavelength of the cosmic background radiation that we talked about, they found that if you go in the past, and the way to check what happened in the past is looking at some galaxies that they travel some thousands or millions light years ago, So then they didn't, some lights didn't get to them, and still didn't get to them. This is for the future, and for the past, that the light had reached to them a long time. And by measuring this, they found that around a few hundred years ago, not few hundred years, few 100,000 years ago, that the universe general temperature was about 5.08 Kelvin. So the temperature had dropped from 5.8 to 2.73, and then they are keeping repeating the experience to find out that the universe actually is cooling off. And this really in line with the theory of the Big Bang, because what the theory of the Big Bang stipulates that one one mass has called singularity, has high energy, really high energy, and start expanding. Expanding is losing energy, then and then gaining more space. That is expanding. This means that the temperature, less energy than the temperature, should drop of the general temperature of the universe. So this is an illustration of the expansion of the universe, and so is illustrating what happened. This is the singularity when that's 13.7 billion years ago happened, and then if you see in this chart, they start coming to form. Now this is keeping expanding. This is a timeline that they put, and then those are some agglomeration of the galaxies like supernova and some the constellation and so on. So now the expansion of the universe by Hubble law, that it's just quantified, and it's talking about how fast is the universe is expanding, what is the velocity. So I'm not going to dwell on this because it's a lot of details with this one. So what we will come up to the conclusion, or before the conclusion, with this thought. There is, so we talk about that the Big Bang is a well-founded theory, and then